Myself Parasani, and today I am going to teach the topic aldehyde ketone and carboxylic acid. So aldehyde ketone and carboxylic acid is all compounds belong to the same category of the carbonyl compounds. So what are carbonyl compounds? So carbonyl compounds, first of all I want to draw this structure of the carbonyl compound. Now the carbonyl compound contains the carbon oxygen double bond. So double bond contain pi overlapping, okay, p pi overlapping, and a sigma bond is there. Okay, so there is a carbon oxygen sigma bond and there is a carbon oxygen pi bond. So this pi bond is formed by the overlap of the carbon's p orbital and the oxygen's p orbital. Now oxygen contains the two non-bonding electrons there, okay, and there are the carbon has a valency of 4, so it has two. It has the possibility to form the two sigma bonds there. Okay, so these sigma bonds can be formed with the alkyl group or with the hydrogen. Okay, there the same possibility is there, alkyl group, hydrogen, and this can be oxygen, this can be NH2, okay, in case of amide, and there can be any group according to the structure or according to the compound we are discussing. If this is carboxylic acid, then there can be OH group and there can be R or H group there. Okay. Now one by one we discuss about these compounds, which are first of all aldehyde. So what are aldehydes? So aldehydes basically belong to the same category of the compound. These are carbonyl compounds, so it contains a carbonyl group. It is obvious that it contains a carbonyl group. Now this carbonyl group has the valency of 4, so carbon has a valency of 4, so this valency can be satisfied by a H. Hydrogen is bonded to this carbonyl carbon from one side in case of aldehyde, and from the other side it is bonded to any R or H group in case of aldehyde. So basically aldehydes are the compounds from one side it is bonded to the H by the sigma bonding, and from other side there can be any alkyl group or any H group. Okay, this is aldehyde. Now the other compound is ketone. Okay, so ketone also contain a carbonyl group. Okay, on one side of the carbonyl group there is R, and on the other side this is R dash. So R and R dash are any alkyl groups, okay, belonging to this category. This is called ketone. Now there is a carboxylic acid. The third compound is the carboxylic acid. Okay, the carboxylic acid contains a carbonic group, and on one side there can be R or there can be H. Okay, but on the other side there must be a OH group, which is a hydroxyl group. So on other side there is hydroxyl group. This is a must condition to make a compound as a carboxylic acid. Okay, so these are some of the basic definitions concerning to this chapter. Now we discuss about the structure of the carbonyl compounds. Structure of carbonyl compound. So it has a planar structure. Okay, so I draw a plane there. And what does it mean if it has a planar structure? That all the atoms belonging to this carbonyl groups lie in a plane. Okay, so it is a coplanar type of structure with respect to the atoms, like oxygen, this carbon, and this R, H, or any atom. They all are in a plane. So they all are in plane. Now this carbonyl carbon is sp2 hybridized. This is sp2 hybridized. Okay, and which type of planar structure is there? So this is a trigonal planar type of structure. Okay, this is an equilateral triangle, and this is that's why this is called a trigonal planar structure. This is a trigonal planar structure. It forms a nearly equilateral triangle. That's why the angle between this bond is 120 degree. Okay, this is approximately equal to 120 degree with respect to this two bonds. Okay, the carbonyl bond and the other bond between some carbon, hydrogen, or a carbonyl carbon. So this is 120 degree. This is all about the structure of the carbonyl compound. Now we discuss about some of the properties of the carbonyl compound. So first property is its polarizability. Okay, this bond is highly polarizable. Okay, so this property is polarizability. Okay, this bond is highly polarizable. How it is highly polarizable? This carbon is electropositive with respect to this oxygen. This carbon is electropositive with respect to this oxygen, and this oxygen is obviously electronegative. Okay, this is electronegative. So it contains delta negative charge, means partial negative charge, and it contains partial positive charge. Now this carbonyl have both possibilities, that it is nucleophilic, with respect to the oxygen because there is delta negative charge, and this is electrophilic, means nucleophile. Any nucleophile can attack this center to form the bond. Okay, there is both possibility arises because of its polarizability. Now due to its polarizability, there is greater dipole moment with respect to some other compounds. If we consider the dipole moment, then we have a carbonyl compound. If we make it a positive, the negative charge, and there is a positive charge, then it acts as a good dipole, negative charge and positive charge, and some distance between them. So that's why it acts as a good dipole and exhibit a greater dipole moment. Okay, so this is all about the polarizability. Now we discuss about its physical properties. Okay, physical properties. So what are its physical properties? The aldehydes are, or ketones, even carboxylic acids are liquid in nature. So that's why we discuss about its boiling point. Okay, so boiling point. The boiling point in case of aldehyde and the ketone with respect to its corresponding butane, or you can say alkane, is greater. This is because of its dipole-dipole interaction. Now what is dipole-dipole interaction? So it acts as a good dipole. In case of polarizability, we understood that it is a good dipole. Okay, so I'm drawing the dipole-dipole interaction. Okay, so this is a good dipole. That's why it is showing the interaction. Okay, with this interaction, there is a good bonding between them. There is a partial bonding between them, and because of this interaction, the boiling point increases. But in case of butane, we saw that there is a weak interaction. Okay, weak van der Waals force of attraction. That's why there is lesser boiling point with respect to this compounds. If I am comparing the butanol, then I am taking the compound with respect to this which is having the same molecular weight. Okay, which is propanol. Okay, propanol is having the same molecular weight with respect to the butanol, and so in terms of boiling point we can compare them. Okay, so the propanol is having the higher boiling point. Okay, so we can compare them. Now the other physical property which we want to compare is miscibility. The other physical property is the miscibility. Okay, now we have studied that like dissolve like. So if there is a polar nature of this group, okay, so this may dissolve in some polar solvent. This may obviously dissolve in some polar solvent, so that's why it dissolves in the water. Okay, if I show the interaction, then it would be like that it is showing interaction with the water, or it is making some hydrogen bonding with them. Okay, it is also showing the interaction with this other molecule, other carbonyl molecule, and showing the interaction. That's why it is miscible in water. Okay, so the miscibility is exhibited because of the dipole-dipole interaction of this carbonyl group with the water.